y equals x. This is the pink line
Me too.
is y equals x. One of the simplest equations to graph. One of the simplest lines to graph. Okay? Y-intercept is 0. We have a slope of 1. We are happy with y equals x. Now, I want you to graph the reciprocal.
Can I do it on some graph?
Please, I want you to do it on the same graph. Graph y, what is the reciprocal?
1 over x.
1 over x. Graphing the reciprocal, 1 over x. You could do what?
An xy chart.
You can do a t-chart. Yeah, do the xy chart. You could. Especially since we're just kind of starting out. Okay, so you said if x is 2, y is 1/2.
Oh yeah, that's what I meant.
Okay.
I flipped my x and y.
I kind of thought you did, but that's why I corrected you. What's some other numbers we might want to put in?
X is 1.
If x is 1, y is
Y is 1.
1. Keep going down. If x is 0, y is undefined because 1. No. So what happens when things are undefined? So at the 0, the reciprocal has an asymptote.
Why is the reciprocal of a straight line so complicated?
Well, before we get into complex functions, I want to know, can we graph the reciprocal as just a straight line?
Yeah.
Because they're going to get
harder,
more complicated. So let's start with simple. So we've gone down from 2 to 1 to 0. What about -1? If x is -1, y is -1.
Oh, this is not a line.
No, it's
Wow.
Two. It's two
Wow.
boys.
What about -2? -1/2. So
I already know what this is going to look like.
So I hope, which saying this, we've graphed this line before, 1 over x. We've graphed the function 1 over x. So at x is 2, we're at 1/2. Okay? If x is -2, we're -1/2. Okay? Really, we only have 2 points there. Is it a straight line?
No.
Is there a time when your y value is ever going to be 0?
No. Man.
Whoa. This is the y value. Is there any x that would make y 0? No. So, in our original function, do we have any asymptotes? No. Our original function, y equals x, there are no asymptotes. That means in the reciprocal, there will be no zeros. There's a 0 in this function, therefore there's an asymptote. So, let's go ahead and graph. It's never going to be 0. Is it going to get close there? What happens as we approach the asymptote? It's just going to decrease, never touch. What happens when we jump across the asymptote? It starts at the top. We're hitting the 1, never touching the x-axis or the y-axis. Okay? No.
From a straight line to 2. Oh no.
Well, no. All right. Are we okay? We've graphed a function. We've graphed its reciprocal. Okay? There are some pieces that I have said that I'm going to repeat again and again, and probably again and again after that. If your original function has a 0, the reciprocal function has?
No 0. An asymptote.
Has an asymptote. If your original function has an asymptote, the new function will have
A 0.
a 0. But if it does not have an asymptote, it will never have a 0. Okay? Moving on. Let's go ahead and graph y equals x squared plus 1. Can I do that? Y equals x squared plus 1. So here we go. way to
How
look
many
at it.
is up one or down one?
I don't know. You tell me.
Down.
It goes up one.
Up. What she said.
What she said. I don't know.
Whatever Elizabeth says, I agree with.
So y equals x squared.
Most of the time.
It doesn't go up one.
It starts at 0. So if I say y equals x squared plus 1, it probably matters where the parentheses are, correct?
Yes. I was about to ask.
Well, I kind of said it as x squared plus 1. If I said x plus 1 squared, then you would have needed another parentheses around it. Then we would have shifted right or left. This plus 1 is a what? Vertical shift. Good job. There we go. So if x is 0, y is 1.
Yes.
Right? If x is 1,
Two.
y is 2. X is 3. Y is 9 plus 1 is 10. It's going to be somewhere up there. Here, we know negative 2. Negative, we're up here. It's a parabola
Parabola.
like that. Yeah, we're going to pretend that that's symmetrical on both sides. Yes? So, can you graph the reciprocal? 1 divided by x squared plus 1. Can I ask you, does our original function have a 0?
No.
No, it doesn't. It never hits the x-axis. So will our reciprocal function
Have a 0.
have an
Yes.
asymptote?
Oh, no.
No. No 0 means no asymptote.
But it will have a 0.
Does our original function have an asymptote?
No.
No. So will we have 0? No.
So we're not going to have either?
We're not going to have either.
Oh, you
What
set us
is
up
this?
for a trick question.
What is this function going to look like? Do you want? Because
The
my
inverse.
question,
The
is it just going to be flipped
flip.
over?
Yeah, that's what I'm trying to say.
So can we get a negative y value out of here? Can we plug in an x value where y value will be negative? X is negative 5. Squared? Oh man. X
It's
is,
just going to be a weirder looking one of these.
it's going to be a weirder something looking. So this one was kind of a trick just so that I could get you to think
Well.
outside the box, I guess. I don't know. So if you want, because I know that you do, want to do a t-chart. If x is 0, what is y?
Undefined.
What?
Wait. 1. Just kidding.
Simply 1. Plug it in.
Another 1. Don't
Because
persecute
X
me.
is 1, Y is 1/2.
Yeah, Owen.
If x is 2, y is,
1/5.
okay. What if we started plugging in negatives? What if x is negative 1?
I mean, 1/2.
It's still 1/2.
I'm going to guess 2. Negative 2 is 1/5.
Negative 2 is 1/5 because we're squaring the x's.
So it's just like a wider.
So we have 0,
But it doesn't go up. It goes awkwardly down.
It just all
1,
It just awkwardly, sadly drifts down.
and we have a half, and then we have a fifth. Oh, that's really on the line. It's not supposed to be on. But it never touches the line. Why? Because there are no zeros in the function. We cannot plug in an x. It's not a straight line. It should be a closed like that. At negative 1, at negative 1 we're a half still. And then the fifth.
It's just a melted parabola.
Melted parabola. It almost
Looks like a continuation of all
It
that.
almost looks like a continuation of that other side.
So how are you gonna know, like, on a test, if I know that this line just doesn't go like this or not?
Well, for the most part, we're going to do them on separate graphs.
Oh.
Yes. All right. But something I didn't connect but I'm going to connect on our last one. Ooh, where did that come from? Where were we the same piece? At 1.
Oh.
If you ever have a y value of 1, the y is 1 here, the y is negative 1 there. Y value is 1 or negative 1. They will be the same at both points. It will be on the reciprocal function and the original function. Okay, does that make sense? So that if I did not put on a graph and a chart and give you an equation, could you sketch the graph of a reciprocal function? Ooh, you don't like this all of a sudden. Maybe.
I already didn't like it. That's okay. Let's keep going.
Oh, so you're just gonna give us a function.
I'm not going to give you a function. I'm going to draw a function. I'm going to draw a graph.
Oh no.
Okay, and I'm going to say sketch. On these past ones, we can actually graph them. Sometimes we just simply sketch. So if I have, it is pretty sketchy.
That was funny.
We're going to say this is at 2. At 3. I think you can figure out other stuff. I won't do the other half of it. How about that? I'll just do this half. Do that half.
Which one do you want us to find reciprocal?
Both. This is one graph.
Like it's one equation for both of them?
Sure. It's going to give you multiple lines in a graph.
Oh, because this one is just like this.
I don't know the difference.
I'm going to say no. Absolutely not. You cannot, if I haven't said, okay, so here we go. I'm going back to this one.
Is she like cheating the system, or she's like outsmarting the drill?
She just made an assumption that the vertex it was going to go down. Why did it share a point here?
Because it was at 1.
Because it was at 1. What happens, so this will not be the case for every parabola. Not at all. Okay? Going forward. What happens at 3? What is it?
It's a 0.
It's a 0. So what is going on at 3?
An asymptote.
There's an asymptote.
Yes.
Good job. There are some key rules. Okay? Y equals f of x, or this is the graph of f of x. Our purple is going to be the reciprocal. 1 over f of x.
But it can't be negative.
What can't be negative?
Why can't be negative?
Okay. So, what's happening here when we have a y value of 1? It's going to share a point. Is there another point on this parabola where we're at 1?
Yeah.
Yes. It's at 4. Okay? So those 2 points will be on our reciprocal graph. Okay? So I'm going to switch. I'm not going to look at that one just yet. Now I'm going to go to the other one. We have a negative 1. Will this point be on our graph? Why? Because it's at negative 1. The y value is negative 1. What happens at negative 3? There's another asymptote. Okay? Those are things we can tell for sure. Okay? Now we're going to start sketching. These, I have 3 points and 2 asymptotes. Okay? Now, this green line, I'm going to start over here with this section. Okay, I'm going to really erase that. I don't want it being there. Okay? Erase that circle. But going from this asymptote left, is our original function positive
Yes.
or negative? It's positive. So 1 divided by a positive number. Okay? It's going to be positive. So going from here, that direction, it's increasing. Right? So when we take a number that's increasing and we put 1 divided by it, what's if we're going from a half to 2, it's increasing. 1 divided by a half is 2. 1 divided by 2 is a half. Oh, I don't know if that was a good analogy.
I hate to ask this now, but are you recording for Caitlin?
I am recording for Caitlin.
Oh.
Wait, so if
Okay,
I'm
keep
gonna
going.
be connected?
We're good, I can concentrate.
No. Not necessarily. Because we're going to hit at different pieces. Okay? Really, we'll really stop right there for this one. And this one will start over here, ultimately. Because it really is kind of 2 functions. I just did 2 individuals and then put them together for this one. Which that's what the book will do. So here, if we're increasing positive, we're going to be decreasing positive. So where should we go as we go to this asymptote?
Down.
Down. But we still need to be positive.
So don't touch the 0 line.
So don't touch the 0 line.
The x-axis.
Okay? What happens is it's approaching 0. As it's getting smaller, as our original function is getting smaller, our other one is getting bigger. 1 divided by. Okay? Now, what have we talked about over the asymptote? What happens as we're going increasingly big here?
As you're small.
As we flip, it always jumps negative. The only other point we know,
But you just awkwardly go to -1 instead of going all the way up.
yeah, because it could do what? It could jump, connect to this, and go up.
That's what I was thinking. That's
Because
what I was looking at.
ultimately we can, and if I'm sketching it, I'm probably going to go ahead and connect them. Because eventually, I didn't say that there's an asymptote here with this parabola, because it can jump over the line. So it's probably technically not a function if I don't put an asymptote there. Okay? So what's happening here? We're positive, right? As we're approaching this point at 2, we're positive.
You just do the same line you did in the graph before.
Then we're doing the same thing. It's getting smaller, smaller. And I'm going to go ahead and connect it here. Which technically, I get torn with that one because this one can cross over. So I'm just going to leave it at that.
Then you increase.
Now here we're positive. We're getting smaller. So we're increasing big. Okay? Now, what I've said happens after an asymptote. We always jump below and come up. But after this asymptote, it's positive. It's going to be another one of these. Why? That is one ugly graph. They're going
I mean, mine looks pretty good.
to get even uglier. You will look at square things when you have parabolas and squares is our exception to the rule, actually. I forgot we haven't done that officially. When they will mirror on the other side.
So we have to just draw the reciprocal. We don't actually have to like write a
You sketch.
sketch the reciprocal.
Yeah. So we don't really know what this reciprocal looks like. We just can know some general things. Okay? So if we do the one in the book, okay, they do a graph of a line. All right, do you want to look at their ugly parabola and random line on page 147?
Is it easier than yours?
I say no.
She said it was ugly, so.
I mean, they do a slanted parabola and not a straight line.
Do you just want to come up with another one?
Should I just come up with another
I
one?
mean, you can. I think you're smart enough.
Oh, it's just such a
Oh, especially in this class.
It is okay.
It's because I'm not the best at math, so.
And I mean, at least I draw and make it where you can see where
Right.
they're hitting ones and negative ones and zeros and stuff like that. And this is the last example in the book for this. Really, their only example in the book like this. But I'm going to go back to a chart just because it helps. Okay. Here we go. Their parabola hits at -3 and -1. And it goes this way.
Miss Becca. Kind of random, but I do.
Okay, Missouri mission trip.
Yes.
Guess who showed up?
Grace Keesley.
Grace K. And then we FaceTime with Becca.
Yeah, because she works there.
Well, I did not know that.
Becca told me that Wednesday before y'all left. Because y'all left on a Tuesday, so the week before. She's like, guess who's going to be there at the same time as PCA trip? And I was like, who? She's like, Grace K. And I was like, oh, yeah. Too bad I didn't go.
Well, I was not aware that she was going to show up.
So did you have a nice little
Oh, yeah. We had dinner together 2 nights. Tuesday. I think I'm going to send her this just so we can hear her talk about it.
Okay.
Sorry, class is over. Ah!
What? Wait, can I
10:05.
draw this?
Draw this
So we can do it tomorrow.
so we can do it tomorrow. So you should have some points with -1 and +1.
Okay, let's do this.
And you should have some zeros. So you should have some asymptotes. And I will go ahead and tell you the y-axis is an asymptote in the original. That's something else you need to know. Y-axis is an asymptote in the original.
Oh, it says -1. I thought it said 4. I was going to say, I don't think you know how to count.
That is -1.
I got it. Good. Okay, cool.